Whenever you are asked to solve any trig equations where you're solving something like, so I might ask you to solve sine of x equals 0 for negative 180 less than or equal to x less than or equal to 180. Ooh, fun. I haven't gone from 0 to 360 because I know you know the answer for that one. So what I'm going to do is I'm going to draw the sine curve. But you know, sometimes you've got to go backwards. So you know how the sine curve starts here and it goes up and down, and that's 360, and this is 180, and this is 1, and this is negative 1. That's the sine curve. But this time I'm asking you not from 0 to 360. So if I did ask you to solve this from 0 to 360, what are your answers? So actually, I'm going to ask you both questions. I'm going to ask you to solve it for 0 to 360, and then I'm going to ask you to solve it for 180, negative 180 to 180. So I'm going to ask you to do both. All right, so part 1 and part 2. So if you have to solve for 0 to 360, what are your answers? X equals. Now when you do those, so whenever I'm asking you sine x is 0, sine x is 1, or sine x is negative 1, you do not use the 3 steps like we did yesterday. You sketch the function. You sketch it. So whenever you're asked for, so if you are asked for sine x is 0, 1, or negative 1, you sketch. All right? Same with cos x. If you're asked for cos x is 0, 1, or negative 1, you sketch. Okay? All right. Not for tan because that goes up and... But for those, that's really important. Okay? Do not try quadrant 1. It's negative in quadrants, whatever and whatever, and the acute angle is whatever. Your acute angle is going to be 0. All right? So you must sketch if you're asked to solve sine x is 0, or sine x is 1, or sine x is negative 1. All right, so if you're asked to solve it between 0 and 360, what are my answers? Where does sine x equal 0 between 0 and 360? Go. X is 0, 180, 360. But if I asked you to solve the same equation for x values between negative 180 and positive 180, all you do is you continue your curve back, and it just goes backwards the same amount. Got it? What are your solutions now if I ask you to solve from negative 180 to positive 180, including those values? What are your solutions? Negative 180, 0, and 180. So if you're asked to solve there, your solutions are negative 180, 0, and 180 degrees. And I'll just do another one. If I ask you to solve cos squared x equals 1. So this is a little bit similar to yesterday in terms of it being a squared one. What's my first step? Let's solve for 0 less than or equal to x less than or equal to 360. And yeah, we'll just do it that way. All right. Come on, what do? I don't want cos squared x. I need cos of x is, come on, plus or minus the square root of 1. In other words, cos of x equals plus or minus 1. So again, if you're asked to solve either cos x is 0 or cos x is 1 or cos x is negative 1, you have to sketch the curve. So cos curve starts at the top, sine curve starts from the middle. Put in your values, 360, 180. You can put your 90 and 270 in. Okay. And amplitude is 1. Okay, what are my solutions to this? I need cos x to be 1 or negative 1. I'm just going to mark them in on my graph. Here is where cos x is 1, and here is where cos x is negative 1. So my solutions are, and you can put them all together. So if you're asked cos x is 1, your answers would have been 0 and 360. If you're asked to solve cos x is negative 1, your answer will be 180. Do you get it? So for this, you've got 3 answers, and you can put them all together, 0, or you can do them separately if you want. A lot of people, like to do them separately if they want, cos x equals 1. Well, that has solutions of 0 and 360. and cos x is -1, that has solution of 180. But then you would have to sort of say, therefore, x is 0, 180, 360. But in this case, you could have just done it in the one step. But often, you know, some people like to do them separately. My solutions for cos x equals 1 are 0 and 360. My solutions for cos x is -1 is 180 degrees. And you could tell me now what the solutions for cos x equals 0 are. 90 and 270. If I asked you cos x is 0. Okay? And if you were asked for negative angles, you would just keep drawing backwards. X equals 1 for 0 less than or equal to x less than or equal to 360. You've got a few different ways to do this. You could just write that cosec is what? What is cosec? You could sketch it. You could say cosec. Isn't that just the same as doing cosec x is 1 over sine x? Isn't this just the same as me solving 1 over sine x is 1? Swapping. I'm really just solving sine x is 1. Does that make sense? But if I just sketched it, I could see it anyway. You can just do it by sketching. 180, 360, 90, you know, it bounces off, remember? Asymptotes there and there. There you go. You can actually just read it from the graph. What's the solution? You can read it from the sine curve, sine 90, or you can read it from the cosec curve, cosec 90. So my solution is x is 90. Okay? You could just sketch, I'm fine for you to sketch the cosec curve if you want. Okay? All right, and if I asked you for cosec x is -1, your answer would be what? 270. And then you could do a similar type of question for the sec curve as well, which is the inverse, which is the flip, of the cos. Okay. We're going to solve from 0 to 360 angle alpha. We're solving this tan of alpha minus 45 degrees equals 1 on root 3. Okay, now, you know when we did, if I did tan of 2 alpha, you would have multiplied each of these by 2, wouldn't you? I've got a new domain. That is the domain for alpha. It's from 0 to 360. How do I go from alpha to alpha minus 45? I subtract 45. So if the domain for alpha is 0 to 360, that's my domain for alpha domain. My domain for alpha minus 45, you have to fix it up, is each of these values minus 45. So it's from negative 45 through to alpha minus 45 goes from negative 45 to 360 minus 45 is 315. So, again, what we were doing yesterday, don't worry that this says alpha minus 45. Let's just follow the rest of the steps. Just pretend that this is tan of that equals 1 on root 3. All right, first step, which quadrants? Look at the 1 on root 3. Is it positive or negative? So tan is positive in quadrants 1 and 3. Step 2 is the acute angle. It's not the acute angle alpha. It's the acute angle what? Alpha minus 45. All right, tan of what is 1 on root 3? Tan of 30. So let's put our answers in. Alpha minus 45. It doesn't matter that it's alpha minus 45 or 2 alpha or 3 alpha. It's that equals... How would you do it normally? So we've got quadrants 1 and 3, acute angle 30. Name these, like tell me the size. What do we got? 30 and 210. Now, tell me how, if I've got alpha minus 45 is 30, how do you solve? You plus, yeah. Now we just plus 45 to each of these. So yesterday we were dividing by 2. Today we're adding 45. Same steps. So that's 75 degrees and 255 degrees. And that's how we do them. As long as you, look, some people like to substitute this and go tan of u is 1 on root 3. They get all their answers for u, and then the very last step is the only different thing where you would then add 45. All right, so please don't start to try and work with this throughout. It's a last step thing where you fix up the minus 45. Oh, sorry, and also let's just look here. Look, our questions do lie within 0 and 360, and our alpha minus 45 values do lie between negative 45 and 315, so that's great. Okay, I may have a problem, but if I asked you to do the negative one, let's say I asked you to do the negative one, that would have been quadrants 2 and 4. 2 would have worked, 4 would have been on the edge. We'll have to do one of those. Let me try. Oh, sorry. I asked you to solve this. Tan of alpha minus 45 equals negative 1 on root 3. Okay, very similar, but different. Right, step 1, tan is negative in which quadrants? 2 and 4. And step 2, again, the acute angle alpha minus 45 is still the same, 30 degrees. I'm going to do it on this graph here. It's 2 and 4. All right, step 3. Remember, I've got this domain up there. All right, what are my angles? No, it still works, sorry. What have you got? Sorry. Yeah, I got 150. So alpha minus 45, this one works, it's fine. 150 and 330. And alpha is adding 45 onto each of these. 195, 375. Ooh. Now, I've got a problem actually. Yes, I've got a problem. Right, stop for a sec. Yes, this is a great example. Can you see that I'm out of range? I'm out of range here. 330 is beyond 315. But what I have to do, I still have to get those two answers in. This is out of range. I've got to cross it out, right? So I went 150, 330, but I say, no, gone too far. You know, I'm allowed to do negative angles. I'm allowed to go up to negative 45. So I've got to stop and come back. So I can get this one in, but the problem is I'm not getting that one in. So, because it's out of range, so I must be able to get it from the other side. So how do you name this? Going backwards, negative. So instead of 330, I call this one negative 30. Are we okay with this? All right. So that is out of range. So now what do? I go, I'll just set this one out properly. So I have to cross out 330 because it's out of the range for alpha minus 45. So alpha is 150 plus 45. I don't use that one. Negative 30 plus 45. Oh, look, I'll put the other one, 330 plus 45, but then I'll cross it out, all right? So I've got 195 and 15. And I've got 375, but that's out of range, all right? So the two will fit, but if it's out of range this way, you have to go back because we're allowed to use the negative angles. You go back the other way to get it. No, you can't just have one answer, you'll lose a mark. There are two answers because you do have a full revolution. See, initially for alpha, you've got a full revolution. So you have to have two answers. You know that tan will be negative in quadrants 2 and 4. You have to have two answers. All right? Now, it did end up going back to positive 15. But this one here was negative 30. All right? All right. Same method. Remember, I didn't ask you to draw the curve for cot is 1. It's only the sine curve and the cos curve. So what's cot related to? Tan. Okay. So we know that tan of 45 degrees is 1, don't we? That's what we know. So what's cot? Isn't cot of 45 degrees equal to 1 over tan 45, which is also 1? Okay. So tell me, so anyway, let's just do quadrants first. So cot will be positive. Cot is positive. This is not a negative one. This is a positive one. Cot is positive in which quadrants? 1 and 3. It's like tan. So cot is positive in the same quadrants that tan is positive. So cot is positive in quadrants 1 and 3. So our acute angle, alpha plus 60, is what? 45 degrees. So we've got quadrants 1 and 3 with 45 degrees. So therefore, alpha plus 60, now just got to be careful here. What's the alpha plus 60 then? Oh, what haven't I done? So 0 less than or equal to alpha less than or equal to 360. What have I got? Alpha plus 60 goes from which values? 60 to 420. Okay, let's start listing out our solutions. Oh, the first one's 45. Is that in or out? It's out. So the next one is, what's the next one? 180 plus 45, 225. You're allowed to go past 360. Can you see? So I missed the first one on the first time around, but I'm going to get it on the second time around. What I'll do, let me just show my working. So I've got 180 plus 45, 360 plus 45. We okay with that? So I can't get 45 on the first time round. It's out of my domain. So I go 180 plus 45, good. 360 plus 45. That's 225 and what's that one? 405. That's alpha plus 60. Therefore, alpha is, what do I do to each of those values? Subtract 60. What's that? One what? 165, I hope, and 345. Do they fit between 0 and 360? Yes. Now, just showing you another way. In your first step, if you're trying to solve cot of alpha plus 60 is 1, you might want to write it as 1 divided by tan of alpha plus 60 is 1. So basically, you're just solving tan of alpha plus 60 is 1. You okay with that? I think that might be a bit of a safer, because I'm saying cot of, to solve, you're really just solving this. Tan of alpha plus 60 is 1. See, because cot of alpha plus 60 is 1 over tan of alpha plus 60. Do a half cross multiply. Tan of alpha plus 60 is 1. That's what you're really solving, which is what we drew. And then you could continue with that. All right? I think that might be safer.